All right, so we're on number 10. We're going to go ahead and draw a picture of this. Let R be a triangular region. So we're told it's going to be a triangle in the second quadrant, with these being your vertices. So 0, 0 is the origin, negative A, 0. So here's your point, negative A, 0. And then 0, B. So this is our triangle. You know, it's together so far. Okay. This is going to involve y equals mx plus b from algebra 1. Okay, just as a heads up. Slope and stuff. Yeah. So we are going to revolution around x-axis. So your ghost shape would be down here. Is there a hole in it or not? No. And what would that look like three-dimensionally? Like a cone? You're seeing it? Yeah, but you can't put anything in it because it's solid the whole way through. All right, so we're going to set up an integral. We don't have to actually we can't evaluate it because all we have is a and b, right? But we're going to set up an integral. So it's going to be pi r squared dx. What would be the boundaries? Yeah, good. Negative a to 0. You know, these will all be multiple choice on this section. So like right there, the boundaries, you can narrow it down based on that. And then you need the equation of this line. So it's y equals mx plus b. Here, I'll write it off to the side here. Y equals, what is your slope? If you go from this point to this point, how much up and then how much over did you go? Rise over run. Good. B over a x. It's your mx plus, what's your y-intercept? B. Do you see right there? This one? Okay. So that is what goes in these parentheses here. It looks like gobbledygook, but that's the answer. So this line has a positive slope. You go up and then over because the A was negative. Because if A was over here, it would go down and have a negative slope. We're going to do 13 next. See how there's a C next to it? That means you get a calculator for this one. Again, on the test, I divided it into 2 separate sections. So let R be the region in the first quadrant bounded by, 1 plus sine of x. First of all, what does just sine of x look like? It's a wave, and it starts at 0, 0. Good, perfect. This one just moved up 1. Okay, so let's just draw a quick sketch. I'm going to label pi over 2 pi, 3 pi over 2, 2 pi. If you in your mind know what those are, you don't have to label all of them. I just did it because I'm doing the problem in front of everyone. So just instead of starting at the origin, you're shifting the whole thing up 1 unit. So it's going to start at 1 and then go up to 2 and then come back to 1 and then down to 0. Like, do you see what I'm saying there? Like, it's still a wave. It's just moved up 1. So like that. So R is the region in the first quadrant bounded by that and, well, it's in the first quadrant. So that and the axes. So this is the part that we're looking at. The part I shaded in there. And what are we revolving that around? X-axis, cool. So your ghost shape, this one's going to be kind of neat. Your ghost shape would be like here. So it's like a Hershey kiss, kind of. And are you envisioning it? It would be round. What do you think it looks like? I see it. Kind of. You're missing like the bumpy part at the top of the heart, but you know. Yeah. No, I'm glad that you're trying to use your imagination. I want you to sort of see it. All right. So is there a hole in the middle of it? No, it's solid the whole way through. So it's going to be pi r squared dx. What would be your boundaries? Well, 0 to 3 pi over 2. And then in there, you're going to put 1 plus sine x. It's upper minus lower, but the lower axis is the axis, so it's 0. So yeah, just 1 plus sign of x goes in there. Make sure you're in radians when you, or does it say setup, or do we have to know what is the volume? We have to actually work it out. Make sure you're in radians or it's not going to work, because trig, you need to be in the correct mode. If you pass your calculator over here, I'll look at it. All right, go ahead and flip over. I'm going to try and get through 14, 15, 16, 17. We'll see what happens here. All right, this one's also a calculator. What is the volume of a solid generated when this region and the lines x equals 0 and y equals 3, oh, is revolved around the, what's your other big clue? It's dy. XU. Okay, so it's going to be a dy problem. I would go ahead and make a little table for this. We're going to plug in for y and get x. What do you want to try and plug in for y? 0 is a good choice. 3 is also a good choice, but we skipped one. -1, there it is. So if you plug in -1, what do you get for x? 0, good. If you plug in 0, 1, and then if you plug in 3, you get 2. It'll be a parabola. So go ahead and plot those, and it should look, paraboly. Actually, it'll only be half a parabola though, because it was just a positive square root. We didn't have the negative square roots. All right, and then you've got x equals 0, which just is the y-axis, and then y equals 3, which will be right here. So this is your shape. All right, and we're going to spin that around the y-axis. So here's your ghost shape. Is there a hole through the middle? No, and it's like a cereal bowl. You cannot put any cereal in because it's literally solid the entire way through, all right? So it is going to be pi r squared dy. And you want y values for your boundaries. So that would be where to where? Good. These are awesome with those boundaries. -1 to 3. And it's going to be right graph minus left graph. But the right graph just is that. And the left graph is 0. So like, it's just that's going to go in there. So square root y plus 1. Now you get a calculator for this, but it's actually really simple. You almost don't need it. And when you go to type it, do you see that the square root and the squared are going to cancel? So I would not even type them. Less typing, the better. Okay. And again, use X, even though it says Y. You have an X button. So that's actually all you have to type. Alpha, and then you have to find it on there. That's why X is so much more convenient, because it's just a one-tap button. So when you take BC calculus, I can explain what the rest of those are to you. They're different modes that the calculator's in. You have to change the mode to get those. Ask Jacob.
You probably did it.
Yeah, with me.
No, so you're trying to teach me how to do calculus.
Oh, okay. Well, I can show you, but not right this second, because I want to try and finish this. But you have to change the mode the calculator's in. Like, we do parametric functions. That's what the t is. We do polar functions. That's what the theta is. Change. It doesn't work that way. Did anyone else get what I got? Okay. Moving on. All right, washers. I'm not going to say that on your test. You have to figure out that there's a hole in the middle. All right, let R be the region enclosed by the graph of y equals sine of x. So we're going to do what we just did on the other side of the paper, except it's not shifted at all. It's going to start at 0. I didn't label the x-axis this time because, I did on the other one, and you guys get it. Oh, and actually, we only need that from 0 to pi. Do you see that? So you actually only need this like first arch of it. So you really don't even need this part at all. All right, what are we spinning that around? Revolution. y equals -2. So is this gonna be dx or dy? Good, it's like you just shifted the x-axis down a little bit. So your ghost shape will be like this. And so the outside radius goes all the way to the edges, and then you have this hole in the middle. What would that look like? It would be round, you get what I'm saying? It'd be like an inner tube. Or a donut.
That's not, or who's the?
Oh, yeah. I like that. Cool, but you're envisioning it. I like that. All right, so it's gonna be pi r squared minus r squared dx. What would be your boundaries?
Oh, goodbye.
0 to pi. Now it's gonna be upper minus lower. Look it. What's the upper one? Sine of x minus the lower one, -2. So it's sine of x. I'll go ahead and write +2 for this one. It's minus -2, because I think you guys have got that. All right, and then the inside one is just from here to here. The upper one is actually just 0 minus -2, which is just 2. The other thing you can do is look at it and go, oh, this distance is 2. It's non-calculator. Yeah, there's not a little c next to that one. Oh, but did it say just set up? Oh, it just said write an integral expression. So we did that. We're done. Go us. Moving on. All right. Let R be the region bounded by the graph of 2 minus x squared. What's that going to look like? Parabola that is upside down and moved up 2. So you're going to have 0, 2, 1, 1. And then what do you get if you plug in 2, -2? So like this. All right, and then below by this graph, another parabola, but this one has been moved which way? All right, down 1, and it got stretched a little bit. All right, so you're going to start at -1. And if you plug in 1 to this, you're going to get 1. This is where they intersect, because that one got stretched out a little bit. So this is your shape. Right in there. This one's hard. There's 2 different graphs there. All right, we want to spin that, revolve, revolution, around what line? Y equals 5. So is it going to be dx or dy? Good. It's like you just took the x-axis and shifted it up a little bit. All right, so pi r squared minus r squared dx. I'm not even going to try and draw this one up here. Like, can you imagine this going around like this? I can't draw it. I'm just going to embarrass myself. All right, what are your boundaries? Good, -1 to 1. Now watch me point to this. It's going to be upper minus lower. What's the upper one? 5 minus the lower one is all the way down to here. So which parabola is that?
The first one.
5 minus the 2x squared minus 1. Oh, this is the one we have to do by hand. I remember this one now. All right, and then the inside part, it's going to be 5 minus the upside down one. Do you see that there? We're going to have to do a little bit of algebra, but I believe in you guys, okay? Kind of disappointed. I don't know if I'm going to finish this, and I have 17. My video is going to break again, but that's all right. I have tons of tiny little videos. All right, so in these parentheses here, if you distribute that negative through, you're going to have a -2x squared and then +1. So 5 plus 1 is 6. So that's what we end up with for that one. Minus. And then what will you get for the second one? 3. Good. Plus x squared. All right, still with me? Okay, because here's where it's going to get really nasty. That wasn't so bad. See how it's 6 minus 2x squared squared? What I need you to do is imagine 6 minus 2x squared times 6 minus 2x squared. I'm the messenger, okay? I found it on AP Classroom. You gotta know how to do it. Plus, it's just algebra. 6 times 6, 36. Now you would have minus 12x squared and minus 12x squared. Do you see where I got 12? 6 times 2. So it would be minus 24x squared. And then negative 2x squared times negative 2x squared will be positive 4. Good, perfect. Minus parenthesis. We're going to do the same thing with this one. 3 times 3 is 9. You're going to have plus what? The only saving grace is this one, everything is positive. That'll be the last part. So yes, but hold on. 6x squared, 3 and 3. You get 3x squared and then 3x squared, and then plus just x to the 4th. There's not a 2 with that one. All right, now here's what I would do. You're writing with pen, sorry. If you're writing with pencil, if you distribute that negative through there, they're all just going to turn negative. And then one more step of algebra, we're going to put the like terms together. So let's do them in order. What's the x to the 4th? How many x to the 4th have we got? All right, 3x to the 4th. And then minus, what is it, 30x squared? 36 minus 9, 27. Believe it or not, we still have to do an antiderivative. So sorry. So what's your antiderivative for 3x to the 4th? Good. Minus. Good, nice job. And then plus 27x. You would do upper minus lower. Listen to me, just stop and listen. It won't be that bad because it's 1 and negative 1. And on the test, this is a whole number. So it will be okay. Like it won't be as messy as this one is. Do you get what I'm saying? Okay, so I'm gonna end that there. But it won't, 1 and negative 1, you guys are fine, right? Like 1, deal with 1. And if that's a whole number, you can just add and subtract them all together. I'm gonna try pausing the recording and see if it'll make it past lunch without timing out on me so I can get the one last problem that I have to record in there. We'll see what happens.